recording this. Okay. Uh,
Yeah, .NET is out of question, man.
yeah. Okay. So we have the other one, which is LLVM.
Yes, LLVM is pretty well documented. There are good bindings for virtually any language. Like I know, dude, I don't know, man. Like if you pick like fourth, probably there are like LLVM bindings in fourth. If you don't, you can use C bindings. Like I'm pretty sure.
Man, there's a ton of stuff for LLVM. Holy crap. There's things from 2021, 2022 even. What the hell? Yeah, it seems to be very popular then. So the one that you found first is LLVM HS. Yeah, so it's gigantic. Um, Maybe this is gonna be enough. I hope you know how to use it though, because I don't.
Wait, know how to use what?
How to make code generation with LLVM.
Oh, it's just Wait, my screen, no. Oh man, my screen's blocked. Kill me.
Oh yeah, I should share the screen.
So like it's just picking. It's just an intermediary thing that you're basically gonna not assemble, but just compose the thing to an assembly garbage, and it generates like more or less optimized code already. So and it's portable. So basically, for example, you don't need to compile to I don't know assembly for Arch, like I don't know ARM from some random architecture like
Mm-hmm.
ARM. And that would be nice because who is doing that is LLVM. So you don't need to worry
Yeah, no,
with
we are
that.
compiling to not to bytecode. We are compiling to this intermediate representation. But how to get there? How do you make a compilation process? That's what I want to understand. I never
Well,
did that before.
we can try doing a hello world. But let's do the other thing first,
Yeah, the other
the
thing makes more
entire
sense.
process. I made a hello world. I think
Oh
it's
no,
on
I
my
lied. I did this
Mac.
once, but it was for
I didn't do it with LLVM, to be
yeah,
honest.
I did for a fictional bytecode that
Yeah,
the professor specifically made for that course.
yeah, I made a tiny Java garbage. And I
Anyway,
need to insert the garbage to make it everything more appealing, right?
yeah. Okay, so the first thing that I think we should do is to make a lambda. That's probably the best test.
Yes,
Oh,
okay.
there's a problem. We don't
Oh,
have native functions. How the heck are we gonna test this?
I don't remember what we were doing that we left them.
No, we ended doing like last session we did parsing stuff, and
Hmm.
we also did um what else did we do? We attempted to finish the omega stuff doing the reduction function. We spent a lot of time on reduction, which is okay, but we couldn't uh, well, the function is done, that's okay, but we couldn't make it like we were discussing about, oh, are we doing kind checking every time before we are doing reduction, because this is kind of assumed in the original paper and stuff.
Hmm.
uh, and yeah, we stopped at that point. But like again, I don't think we're gonna have a problem if you don't trigger these potentially problematic functions. So we're talking about for alls and stuff. What we want to do here is something a little bit more simpler. But I just noticed that uh, we don't have a prelude. We need to make one,
Yes, that's a good catch. Actually, I wasn't even paying attention to this.
because the
Okay,
last time
so
we did this, we had at least plus to play around,
yes.
to play with.
Well, we can do one, right? We can do a plus with like piano numbers.
Yeah, could you join uh, the thing?
Oh, Visual Studio.
Yeah.
Just to give me a second. Just let me pick something here.
Okay, so this is gonna be the prelude module. And we're gonna need to import types. Oh. How the heck we're gonna make... Because last time we did this in Erlang, we did the symbols themselves, which was pretty cool.
Yes.
But I don't know
Well,
if we're gonna be able to do the same
strings.
here.
Strings.
It depends, because I think we not changed the native function type.
I don't even
Actually,
think
do
we
we
have
do
one.
we have a native function? I don't remember this type anymore. Yeah, we
I
don't.
don't think we have it. Yes,
Yeah,
we
we
don't.
removed. But we do need a prelude. We do need a prelude.
So our native functions, they were just like variables with a symbol pointing to a type that was an expression that was a native function, right? So
Yeah, but
let's
we don't have the
start.
native function anymore. That's the thing that I'm trying to.
Hmm.
Uh,
Let me
I
see.
think all of them will become e-abstractions, right? Because a plus is
Yeah,
a function that
abstraction.
picks. Yeah, a plus is a function that picks something, right?
Hmm.
And they return another abstraction that picks the second something, and then the final expression is a literal.
Yes, but the final expression is what?
Is the sum of them.
Yes, the sum is the function. That's the problem.
Wait.
Like you're thinking of the signature of the thing, right? But the problem is not even that. The problem is what it makes, which is the evaluation part.
Yeah, but if you take a look on our environment is a text to a value.
Oh, dude, we have a v native
Oh
function.
no, we do have a native function, but it is in a data type that we
Oh, makes
never
sense. It is
ever
a
use it,
value.
which is this.
No, I remember getting to this discussion, and that was okay. Like, how do we evaluate something? Well, the thing that is a value is either literal, right?
Yeah,
Unit. Oh, you the value for a unit. That's right.
yeah. We have a value for a literal also.
I think we could also have the values for bools, but I think we discarded because well, there are only two things to pack, so we left them there
No, no,
anyway.
no. We do have values for Boozman.
No, we don't need to put in there. That's the
No,
That's the
but we are.
point.
It's already there because a v literal contains a literal which contains a bool.
Yeah, so that's what I'm saying. Like we're just packing the options. We don't have a, for example, a v true, v false. Like we don't have that. That's fine.
No, okay. Okay, so everything that we want is basically gonna be a map, right? So it's yeah. So okay, we can start by doing that. Okay, so we need two preludes, I guess. No, we need three preludes, I guess. We need one for the evaluator, one for the typer, and another one for the kinder,
The
which is
kinder.
very interesting.
Did whenever you say kind or kinder, I remember of like children
You
because
remember
of
of what?
German.
Sorry?
Children, like German.
Oh.
Anyway, I just put my Zoomer phone.
Okay, so this is gonna be a map from list, and then you're gonna have a list here, right?
Let me join this. Today's the day, Lemos.
Today is the day.
Today is the day because we don't have Nathan here.
Okay, so
Nathan does things right, and that blocks us. But let's
that
look here.
sounds very like, oh, Nathan is the evil guy, and we are doing a favor for humanity.
Yes. All right. I have the thing here, and I join. I don't want to update. Okay, so let's do the thing. So we have a native function as a value. That's fine.
We just need to make a map, though. It's very okay.
just... Okay, I have the stuff here. What were you saying? Sorry.
Um, okay, we need a map. You see?
No, where you're looking. Let me see. Okay,
Yeah. So
we
I'm gonna
need
grab this
a...
stuff
Mm-hmm.
and I'm gonna paste it here because this file is gonna be the file that everybody will import this guy. So we're gonna have.
Okay, so here's the thing we gotta do. We gotta do a thing that will result into the evaluation of that crap. And what is that magic thing? So we gotta introduce a thing on the expression.
Wait. No, man, I don't think so. Here's the deal.
Why not?
Take a look on the prelude.hs file. So the map that we establish on the evaluator is a map that goes from a text to a value, right?
What?
So
Wait, what are you talking about, man?
I'm talking about making the prelude.
No, dude, like, okay, like you're thinking. I'm not asking about this. That's my thing. Like we're mapping. Here's my question. We're talking about an E abstraction maps to the V closure, right?
Yeah.
What are we mapping to a V native function? We don't have this.
Wait.
So I'll recall to Erlang.
No,
We
no, no.
had a thing that was either an abstraction or a native function. On the evaluation, we
No,
would
but
check.
isn't this an e variable?
It is a variable that has a native function inside.
Yeah, that's what we are doing here. So the text will be a plus.
No, but dude, we don't even have this node. It is not a variable that evolves to this. It is an e native function that happens to be wrapped inside an e variable.
I'm very confused. I'm pretty much certain that in your
Dude,
language did e variable, man.
look at the code. We did an e variable wrapping an e native function. Dude, there's no way you're gonna do this in a variable. We're wrapping a function, a built-in, inside a variable because we want to call it by a name, right? So an e native function is a function. So how do you do things in Haskell? This, right?
Yeah.
So like this would be +1,
Yeah.
right? Actually, let's do a plus. Let's do a plus. So this is a plus, right?
Yeah.
So how do you call this? You don't. So the thing you would do to call this would be with a e variable,
Oh, wait. I am.
variable with a x and some value for the variable that
Okay.
happens to be inside the context, and that's what we were doing in Erlang.
Wait. Just a sec.
We have this stuff here pointing to this shit in the environment. Like for example, we have a map that is
Wait. Can I try
plus.
something? Can I try to explain something and then you can judge if it makes sense?
Yes, okay.
Okay. So my initial idea is okay. Our prelude is composed out of a map that maps text to a bunch of a value, right? And a value in our case can be 4 possible cases. So what is a plus? In my mind, the
Mm-hmm.
plus will be read by the parser and will try to
Yes.
it will classify it as a variable,
Yes.
and then when it finds as a variable, it will try to find in a map. And the map will
Yes.
say, oh, the plus is a variable that returns to you a v-native function that picks a v-literal, in this case is
No,
a
that
L
is already
integer.
wrong because this thing doesn't take this. Okay, we can take this, but that should be a function in Haskell, right? Because we're interrupting.
No, but that's the thing. That's the thing. Let me finish.
Okay.
So this return picks a value and returns a result value. I already forgot what is return. So result, sorry. Okay, so it's an
Mm-hmm.
either. Okay, that's cool. Um, But I was thinking about doing carrying now, right? So you see that you have result on the second part of the function of the vnative function. This will be another vnative function that picks the
Yeah.
second. So this is going to be the first integer. And then I was thinking about doing, oh, this is now another value, which will be v literal l integer,
Okay.
this, and then we need to return a value. So it's gonna be v literal l integer, and then x plus y.
Yes.
That's why I think that the plus and all the things in the prelude, they can be just like variables normally. We don't need to add.
Yes, that's what I'm saying. But we need to enter the environment. That's what I'm saying.
No, but that's what we're gonna do. So this evaluator prelude, can you go to evaluate.hs? Go to the bottom, and then you're gonna see the function
Evaluate.
eval.
Wait. Evaluator.hs.
Yeah.
Okay.
Do you see
Go to
this
the
main empty
bottom.
here?
Yes, that's the
This,
initial environment. We
yeah,
just
but
swapped with the prelude. That's
yeah,
right.
yeah, and then we're done. So that's why I don't think we need to change anything in the.
Oh, I see what you mean. Like, okay, I see what you mean. Like I was suggesting making. We were doing visitor length, but I think it's unnecessary. Like we had another node in the expression that was either this or the other thing, and we had just a Erlang function there. We don't have a v literal and so on.
Mm-hmm.
It's literally just a raw value.
Yeah.
So that's why I was saying this. But that's fine. Like we can just add the value itself here. That's fine.
Yeah, I just don't know if this is the way to go because as you can see here, the vanity.
We don't even need to do this, I guess. Oh, but we want currying, right?
No, it's not that we want currying.
No,
Doing in
we
a
already
curved.
have curry on stuff, so.
Yeah, but doing in a curved manner, that's how I thought
Dude,
about.
are we doing curry? I don't even remember the state of this, but currying in a S expression language, man, that sounds very cursed. I don't remember how we were doing this.
No, I can explain to you. We are doing currying because there's a lot of things in our syntax
Yeah,
that
but
is
here's
easier
the
to the
thing. Are we
user.
doing cur? No, but wait. Are we doing currying with like exposing that in the language itself, in the way the language works? Because I know
No,
there's
we
a
are not
difference, right?
exposing that.
Yes. Okay. So that is the difference because I know we mount the stuff like seemingly and just mount as currying, but we don't have the currying by default, right?
Mm-hmm.
Okay. So that's less troublesome.
Okay, so um, oh man, this function is gonna be terrible. Okay, let's just write this here. So this is gonna be something that picks a v literal and a literal, and then we need to do case literal of. If this is an L integer with something, then we return because this needs to be wrapped in an either. Then we return another vnative function. Holy, yeah, this is gonna be really painful because if this is something else, we need to do left, and then we need to say, oh, I don't know, um, sums only work on integers. But we also have rationals, right? So this is also potentially a rational. This is completely the poor's min version of type classes. There's no question. So then we do
Just a second. Let me close the door.
only work on numbers. Okay. um,
Okay.
let's say fun2, which is exactly the. Wait, am I saying things correctly? Our function is a vnative function that picks a value. The value needs to be a number because if it's not a number, this is not plus.
Yes.
But the problem is that this needs to return a result value. So if you have an error, we return left. If we
Yes.
return anything else, then
Oh, the
this needs to
golfer's
be
here.
a right. Yeah. Hello,
Hello,
Victor.
golfer.
Uh, But this return is another native function, right? Because this is the second part of the sum with the second guy.
Mm-hmm.
What the?
Dude, okay, let me...
Wait, there must be a way of doing this in a prettier way.
Wait. So let's do it here. So case, it's a literal as an integer or blah blah blah. We just have these two numbers, right?
Yeah.
Dude, with subtyping this would be a lot easier because we just have like a class of numbers.
Yeah, then we would be making type classes.
Not necessarily like subtyping is not necessarily type classes. Like F# has that.
Yeah.
It could be with object garbage as well. But let me see. So okay, so we return right is the correct, right? It's the right.
Yeah,
value.
right is the right one.
Oh, dude, this is so terrible, man. Okay, if that happens, we're gonna return.
We need to do the same stuff, man. We need to do the same pattern matching to the second. That's
But
why I think that there must be a smart way of doing this.
Wait. But here's what I'm questioning. Do we need to do this currying? I don't think so.
You don't think so?
Yeah, why?
Because
Does
our native
have
function
curry?
picks one value at a time.
Well, okay, I see. For that, we would need to do tuples and do
Yeah,
like,
yeah.
receive one value, which is one
That would be
tuple.
cursed. That would be really
Yes.
cursed.
Okay, I see. Okay, I get it. So I get the problem. Okay, so we just spit a new thing with the value closed. So, okay, it's the same garbage again. That's gonna be horrible. How do I copy this garbage? I changed my
Control-C.
keybinds. No, it's because I changed the... Sorry.
There must be a smart way of doing this. We're just being dumb.
Oh, it is a smart way. You
No, it's
copy.
not. Copy pasting is not the smart way.
What do you mean, man? What do you mean? Victor is pretty experienced, right, Victor? With the right approach to solve problems.
Oh, yes.
Yes, perfect, dude. What are you complaining, man? Literally complaining of nothing. Okay, so
You either do this way or just avoid solving the problem. It's my philosophy.
yes. In this case, we don't return a 222. Here's a question. We are already inside a right.
We are already inside a
This
right.
would be inside an either, right? This would be like this.
Yeah. That's why I think it's wrong. There must be a way
So
of
we
doing
need
one
to,
either.
yeah, the stupid way would be unpacking, doing a do notation, I think, unpacking this garbage, and then just proceeding with the thing.
Doing an unpacking.
Yeah, like you unpack the value out of the other one, and then if it is a right, then it is just a value. You return the garbage. If it is not, like
Oh yeah, okay, that works. That definitely
like
works.
do,
Yeah, do.
and then I don't know, a return. That's pretty bad, man.
No, return
it's
will not
like-
work because this is a keyword. So this is gonna be the
Uh,
second, and
Second,
this is the
okay.
first.
Okay, but here's the thing: we're not applying this. Dude,
We're
this is
not.
confusing. Let me remove this garbage. So what do we need to do? Let's just do the peer.
It needs to be peer first plus second, right?
Second plus first. Okay. And then what is the second? The second needs to be a number
Yeah,
wrapped inside a right or left,
yeah,
right?
yeah, exactly.
So let's see what we do here. So we do. Oh, but dude, this is bad. Like we will need to return. Dude, this currying garbage blowed up everything.
This currying garbage.
Yeah, because now the plus doesn't return that. Like the plus. Yes, like oh man, that's okay. That's bad. We're trying to do inside a function because here's the thing: we need to save the state, and then go for the next one. Why this result, man?
Wait,
Okay,
it
it
is
can
result
fail.
because you can fail in the middle of the process.
No, okay, but then this fucks up with the curry. This is shit.
It works with with the
dude,
curry.
because you return, like, think about every case you have on this, like plus, less, whatever. Like, you're gonna have a vnative function wrapping this garbage. So we don't need to do it here again, right? It's already just outside. Like, it's gonna wrap all this garbage, this trash. And then, but here's the thing, it only picks one.
Yeah.
So you need to do another thing that picks another one. So it would be like this.
Yeah, it would have to be a value to a
So
value.
so we don't need to wrap inside that garbage. We just need to do this, I guess. But then we need to call this garbage.
We need to call this garbage. But
Yeah,
that's
because
I think that the evaluator should be doing that, though.
I don't know how we're gonna do this, but we should just return, instead of returning this plus the garbage, we return just the second with the thing inside. The first added up inside this function. You got the idea?
Can you repeat that?
Like it would be let me just do without this clutter bullshit. It would be with the function that picks a y. Second, let's do second. Let me just eliminate this garbage. Dude, I feel naked without my key bunnies. So it would be second, that is first, plus first is just the garbage. We just do pattern matching here to be we cannot do simple pattern matching because we have the rational garbage to ruin our day. So
Yeah, that's another problem, right? Because
so we need to
we
do
need
a
to
case
duplicate
of
we need to duplicate everything double because of the two numbers. There
yes.
must be a clever way of doing this, and I'm
Yeah,
just
but
not
I'm not
figuring it out.
clever. I'm not clever.
I'm 100% sure that this has a clever way.
Yeah, there probably is, but I'm gonna use shadowing and you're not gonna stop me. This I can't do in the same line, I guess. Anyway, you know what I'm doing, right? You just do the other case, otherwise it's just you raise a garbage here. And then you just handle this left garbage. Like if this thing is none of them both, then you just fail.
No, this will not fail because this pattern matching is unexhaustive.
Yes, I'm saying like complete the thing, but that's it. But here's the problem: like we're returning another function, dude. I don't like this curry, man.
I think that we don't have any other option because because this is the
We
only
do.
way
We
to
can
have an
do.
arbitrary like
No,
array of native functions.
not really.
Yeah, no, you can do that, but
That solves all our problems. Don't you dare to complain. This function would be literally a fold that way.
I think this is kind of cursed though.
Nah, man. Perfect. I don't know what you're talking about.
You know it's the best thing is that nothing breaks if you change that to a list because nothing
Yes.
is using that.
So I vote for using it. Exploiting that, actually, rather.
There's a second problem though. If you go to the evaluator.hs and you go to the line 20 where we are pattern matching with an e variable, which will be the case of the plus, we go to the map, we do a lookup with the environment to check if the plus is there. And if the plus is not there, we throw an error saying unbound variable, or we return what is in the map, right, related to the plus. But what is going to be in the map? It's going to be this that we are making right now, right?
Wow, yes, the v native function, yes.
So that's what I'm kind of uncertain because how we gonna I don't remember anymore how we dealt with this in Erlang because this will return this.
It would
Where
be
are
funny
we
if we didn't.
where are we grabbing the things from like the numbers and throwing them to the native function? I don't think we did that.
In Erlang, we were just having a list, and then on the function evaluation, like when you do an application, we just check if the first thing is a variable that is reduced to a native function. If it is, then that's it. We just like call the stuff on a fold in a list. That's literally our Erlang garbage.
Yeah, but I can't see. I'm not
Ah man, I'll
understanding.
do that. I'll do that. And you're not gonna stop me.
No, yeah, that's fine.
You're not
Oh
gonna
my god,
stop me,
there probably
Dennis.
there is a reason Nathan didn't do it with the list, man. But okay.
I if there was a reason he should show up here, because honestly,
Probably there is a reason
that I do not care.
that we are literally ignoring.
Yes. Are you having dinner, Victor?
No.
Dude, I'm actually struggling to see where my perfume is.
Dude,
Like
I
the
had the
website's
feeling you were
literally
gonna talk
blocking
about
me.
perfume.
This is record. We are recording, okay, Victor. So
Oh,
Oh,
sorry.
you're gonna be on YouTube. No, it's
Is
fine, man.
perfume
It's
a
fine. You can
cuss
talk
word?
about the Jeremy fragrance.
Is perfume a cuss word here? And I don't know.
Oh, man.
No, I just
Okay.
want to see the tracking number, and the site is literally
oh, I
blocking me.
see now. Where the thing will come from. You want to do? You want to do in the form of a list, Magita?
Yes, that solves a lot of our headaches.
Okay, so yeah, exactly like
Wait,
that.
my
And then you do a fold.
wait, cause my no, sorry. Oh man, how do I?
I can undo that for you.
Okay, thank
Oops.
you. Let me just do this, cause my wait. Okay, never mind. Let's just do it again. So numbers, which is now a list, and then and then we fold.
Oh,
Let's
this is
see,
so cursed because I think you're gonna have to do the logical operators in again.
fold left with a plus. Is that how you do? Just a plus?
Yeah, just no. Yeah, I need to wrap in parentheses. Yeah.
Okay. So plus, let me see, and then we do.
0 because this is
Yeah,
the
but wait, we
accumulator.
need to do a case of, right? This is okay. We need to worry about the types,
We
right?
need to worry about the types.
So let's do it outside because this will be nasty doing here.
Yeah, but there's a problem.
Mm.
I don't remember our parsing returning like a list of stuff. Do you remember
Our
that? Because we did
parsing.
that in Erlang in the other in Spoon and the
No,
knife
it
one.
does a return a list of stuff.
It does. Are you sure?
No, it does. It does. It does. It does. That's true. We can look right now, but I remember it does.
Are you sure we are returning a list of numbers?
Dude, everything was a list. Yeah, because we had the variadic garbage.
No, but you don't have variadic garbage in here.
Yes, I know. What's the problem?
Okay,
We would
just
need
just
to
continue.
adapt
Maybe
it.
I am confused.
No,
Just
but
continue.
here we would need. Let me see. So on an application, right? It's gonna be how in the ST. Can you write me the ST
The ST for what? Sorry.
for like an application for like two arguments, a function with two
Mm-hmm.
arguments.
Okay. So it's gonna be something. Uh, it's gonna be something like this,
Oh, because maybe that is indeed a problem.
and then we're gonna have two stuffs.
And the second one cannot. We have no way of identifying that as a list. They are right. Oh man, that sucks.
Yeah, but then I don't think we can have this.
Yes, we can't.
Which means that we don't have a choice. We need to curry.
Oh no, thank. Oh,
The best part is that this idea of combining things together was your idea, Maggot. That's
oh
great.
man. Okay, let's yay. So let's do the I don't know, v literal first, I guess. Just literal,
Yeah,
right?
and then we need to do a case of.
And then we do first. Let's do a let with second, which is just a uh
It is sum. It is recursive. This is also sum, man.
what?
Right? This is sum. Just that.
Oh, yeah, it is sun again. Okay, that's true. We're stupid. Okay.
And then we
So
can do use
second,
notation because the sum will return an either.
yes, but here's the thing: we need to add.
And then we do the case of with the literal.
Yeah, but okay, sum with what? That's my problem.
Oh, I see what you mean.
Yeah, like we don't have two things.
We don't
The
have two
pain.
things, we have only one.
That's why it's painful. We need to spit a new lambda with the
No, we
side.
can do the
So
lambda here.
what?
Yeah. V literal, literal. And then this thing doesn't require anymore any sort of stuff.
No, but okay, and then you pass a lambda. Is that what you're saying?
Yeah.
Yeah, but then it's no different than what we're doing.
I think it's gonna be shorter though. Then you do a do,
Mm-hmm.
which is gonna be uh, this. And then if it is okay, that means that we can just do return, uh, which means that this is the first.
Mm-hmm.
Oh, but this is also wrapped in.
Yes.
Yeah, but there's a problem. How are we gonna know if this is a rational or an integer? We need to pattern match this guy. There's no other option.
I think it's easier if we do separate functions for each one of them.
Okay,
Like if
but
the
let me
first
let
thing
me
is an
finish this version, and then
okay.
if it's wrong, then we can.
Okay,
Uh,
I will not. I'll close my eyes.
then the return is gonna be this x plus y. Uh, rational. Whatever, actually. Then we return left saying can't sum integers with rationals. Okay. Then we're gonna have to copy paste everything and do it like that. That is also very fine. And then I'm gonna have this. Can't sum known numbers. That's cool. Can only sum rationals with rationals. Like that. Then this also can be whatever. Can only sum integers
Two of my
with
eyes closed.
integers.
Rush. Getting scary.
But this is also wrong because we don't have x and y. We have first and second. First plus second. Okay, what are the complaints? Redundant lambda. Replace with this. Okay, so this is HLint doing a suggestion that we don't care about that at the moment. Yeah, okay. So I guess this works. We don't need a
Beautiful
dollar.
piece of code, by the way.
But there is wait. Wait. I think this is wrong. You know why? Because second, we are assuming that this is returning a validated function, but sum asks for a vliteral already. You see?
Let me see. What is the problem?
The problem is that this guy needs to actually be a native function.
Oh yes, it does. The result, right?
Yeah. And then we need to do
The inner one doesn't need to be, just the result.
the inner one doesn't need to be. No, both of them need to be.
No,
I think yes, bro.
no. The inner one could be just a random. Let me see.
It is
The
because it
inner
go.
the inner one will get wrapped in the outer native function, so you don't even need to put in there.
I don't even need to put it in there.
Like
Because do
I
you
don't
agree?
understand this syntax though. By the way, like what are you doing with this lambda? Like isn't that just unwrapping?
This sum is a function that takes
Yes, I get
a
it.
v literal with a literal and then do stuff, right?
Uh-huh.
So what we need to do,
And okay, and let me read the stuff. And then you have if it's an integer, I will ignore the rest. If it's an integer, you get the first.
yeah,
Is that integer correct?
no,
Okay.
wait,
Wait, integer.
yeah, I think I used
Okay.
double stuff. Yeah, now it is okay.
Okay. If it is an integer, we do second, which is the same function,
Yeah,
and then you do L integer second, which is doing a case.
case of the second, because the second can be a known, something that is not a number also, right?
But you're, dude, I don't understand this. Like, you're not calling it. What are you doing with it?
No, I'm not saying this is correct. I'm just trying to
Can
make a
I
draft.
do what I think in
Yeah,
F
of
sharp?
course, of course.
So
Just do it.
let me do the dumb way. The grug. Some native, whatever. So and then we pick an X, right? And then we have another one that is some second garbage that is just a fun that picks a Y and leads to an X plus Y. Oh, sorry. It needs to be. I'm ignoring the E literal garbage. Okay.
Mm-hmm.
So this will be an OK. And then we do. Let me see. So and after that we need to. We already have the first dude, so which is the X, which is inside this thing, and we already have this. So we just return this garbage. So v native function some second. That's what I thought.
What
And
is the
then, okay,
type
the
of
check.
some native?
The type of sun native. This, the
Yeah.
type would be. Okay, let's do with the proper typing first. So this thing is a value. Wait, no.
Yeah, this is a value. This needs to be a value.
V, it's a. What is the name of the thing? Value, right? Up
Yeah.
there. So value, that's the name. Value, what the heck, man? Okay, so this thing is a value, and this function should return a result
Mm-hmm.
of another value.
Yeah. Exactly.
And what that is, let's do with the types now. Now we need to do a match. I was going to do a case. You're cursing me.
Yeah, match X
With,
with.
and then if it is a literal, oh, sorry, a v literal, right?
Yeah, if it's a v literal.
A v literal with l integer.
Yeah, if
Integer
it's an L integer with a
X,
number.
I'll use shadowing because I don't care. We do this, and this is the return.
And this is the return.
But this is not wrapped inside this result.
That's a problem.
So we need to do OK this garbage,
Yeah.
which is nasty because now you have this
It
and
has
this.
a showcase.
Yes. So Okay, and that's it. And then we do the other case. Let's just do the else, okay? Like I will ignore the rational. And then this is the case where like we got something else. So then it's just error.
Yeah.
And then we gotta do here on the function as well because we're not unwrapping it. So let's do a function that is what, Lemus? You tell me.
It
It
is
is a v literal
That's the
and
problem, right?
integer
Wait, where is
x.
function coming from? Where is function coming from? I'm confused.
Function is a it's just a it's just a shorthand for doing I don't
Oh,
know
okay.
ABC with pattern matching. So you just do function.
Okay.
Uh, just close line and move it here. Okay, and then if we get another integer here, then we do this
Wait.
garbage.
I already have a question for you. Do you
I have
agree?
a problem. I see a problem with this, but go on.
Yeah, maybe it is the same stuff. So my issue is that we need to wrap into V native functions twice.
Mm-hmm.
That's at least from my
Well,
perspective.
not really. You just need to wrap once. That's the thing that I was saying. Like we just need to wrap on the outer one. On the inside, we don't care.
On the inside, we don't care.
Yeah, because the result of here would be a function already, right? That just needs to pick the same stuff. Let me see. So we pick a value and we return this
Yeah, but
crap.
let
So
me
it is the
explain.
same
Let
thing.
me explain. The V native function, it picks a value and returns a result. Okay.
Mm-hmm.
The value can only be one of the two operands of the plus.
Yes.
So it needs to be x. Okay, so it's going to be a native function that picks an x, which
Mm-hmm.
I'm going to ignore the pattern matching with the literal stuff. So it's an x, and then it needs to return a result. Sorry, it needs to return a result with a value inside. That
Mm-hmm.
value inside the result, it needs to be another v native function that picks the second operand. Because otherwise, there's no way we can have the second operand, at least from my perspective.
Well, because what I'm thinking here is you just need this interface, which is a v native function that picks a thing, a value, and picks this thing. And then, okay, how do we change this interface here, which just picks one value? Well, you make a thing that picks two.
You make a thing that picks two.
Yeah, let's think of the type here. Like this thing picks one,
Yeah.
and then we match. Okay, but we need another. Okay, so we spit a result
Of a sum
of
native.
of a thing. So this final thing here would be another thing, another function picks this thing already wrapped, right? This x.
Yeah, but that's the thing. Because there's something else that we can consider that I should share. Because I don't know how we're gonna use it, but I should share.
Oh,
Because
okay.
because
I
everything
think
is wrapped in ethers, we should be able to do stuff like this with
yes, it makes sense.
like x. Uh, no, not like
Yeah,
this.
yeah, yeah.
Like
I get
this,
it.
and then like
Mm-hmm.
this, and then this. This should be
Yeah, I
the
get it.
sum with the
Mm-hmm.
ethers, with everything going on. Uh, but I'm not. I can't see how we're gonna fit that. You see?
Mm-hmm.
Because this, like, I can totally see this being the answer.
Yeah,
Like one
V.
line.
Yeah, it makes sense. This. Oh man, this sucks because it should be now. This. Oh, but dude, wait, we're forgetting something. Okay, my code is not wrong then. Okay, wait. Let me just complete this. I see another problem with this, but let's just stick with this for now. And then here's the other thing. This. So now you have two. See? That's right.
Oh, okay, okay.
Yeah, this is just the helper function should not write it here. But here's the problem I see now. We picked the first thing, which is a literal, correct?
Yeah.
Okay. What happens now? Because on the second one, What happens if we pick a rational? We fail.
We fail.
But what happens if we fail here?
That's the thing. That's the thing. That's why I think we need to do like write, like okay, result, which should be okay, because whatever this is, it's picking a value which we discovered it is an integer. So
Mm-hmm.
whatever is going on after this arrow, it needs to return an okay. An okay with another thing that asks for the second. So this is the second wrapper of the result that I was talking about.
Mm-hmm.
So how I think this is gonna go, I actually think it's easier to write it here. So you pick this and then you do write like that. You see? Ignoring the literal stuff. So
Mm-hmm.
this is a function that picks a value x that you're gonna pattern match and removes what the hell?
It's an okay emoji. But go on,
Our
don't
language
let
will be
me.
able to do that, by the way.
Yes.
So we pick a value, and whatever is
Mm-hmm.
after this arrow needs to be a result, which needs to be okay or an error.
Yeah.
But because we already pattern matched the x and we know it is a number, we're going to return a right, which is okay. This
Mm-hmm.
right needs to ask for the second guy that we're going to pattern match, and if it's a number, we return the okay with the sum of them. But that's the
Yeah.
thing.
This,
This function, this thing that I'm highlighting, I think this is a v native function. Another
yeah.
one.
Both are. Yes,
Both
both
are,
are.
but it's one calling the other. And these okays emojis, they are the okays in the result type. So that's what I think we should do, right? But then we have a problem, which is that this guy is wrapping this guy, right? But there is I don't know if we should, wait, because there is a function. There is a function called join that is able to pick an m of an m of a and return an m of a, right? So, and the either is a monad, so this works. But I don't know if this makes any sense for us, because I think it makes sense to have two okays. You see, it is one
Mm-hmm.
okay because of the x, and is another okay because the y is okay.
Yeah, it does. It does make sense.
So I think we don't have a choice. I think we just need to replicate this code here. So let's do it then.
What a
So
garbage.
the sum native is gonna pick a v literal with something, and then it's gonna be whatever.
Mm-hmm.
But if it picks anything else, we're gonna just return left and say that you can't do stuff with no numbers. But okay, we already know it's a literal. Now what? Now we do a case of the literal, right? It needs to be an integer or a rational, which is this. It needs to be this, right? So if it's an integer, then we already passed the. We should put the first emoji, right? Which is in this case is the right. Okay. Then this needs to be another function that picks, and that's our problem because it's going to be the same exact code,
Yes.
right? So that's why we did the denotation
Yeah, it
before.
is the same. It is the same code, but with one value pinned, right? And that's it.
Exactly, which this value is like in our context, the first.
Mm-hmm.
We need to call the same stuff. Although I agree that this is very weird because we are calling a sum native that calls for other stuff, but because you need to imagine that we are just copy pasting. Imagine that we are just copy pasting exactly this beginning here. And then if this second is another integer, we return. This return is another right. So here are the two emojis, the two okay emojis. This one is to verify is because we checked that the first is correct, and this other one is because the second is correct.
Mm-hmm.
And then we do like that, and we do the same stuff, and then we can remove this, and it works. And then this, is just some
Just.
native.
In the end, you just say it is just.
Is this, right? Is this. There is a better way of doing this though, which
There
is,
is,
yes,
but
there is another way.
do we want to find out? I don't.
Yes, we want to find out.
Oh, man.
Uh, and now, right, instead of some native, we have arithmetic native. You see?
Yes, and then you just pass a garbage in there.
Yeah. And then now, this guy here receives it extra parentheses, and we pass the sum. Haha! Okay, and then we can do the other 4 ones.
You sound overly excited when I'm just that inside.
I'm not certain if this is gonna work, but if it works, I'm gonna be pretty happy. Ooh! No, this sucks.
A lot of things suck, man.
Because we cannot do the same with the division.
Oh, that's true, because the division we gotta do a check.
No, it's because
Well.
Haskell has 2 divisions. It
Oh
has
no.
this for rationals, and it has this for integers.
Ah, you gotta be kidding me. Haskell sucks, man. I never seen a language suck so much.
Oh, you saw that. You
Oh,
already saw. You
I
already
saw
saw
Erlang.
this, so you
I
know
saw
it sucks
Erlang.
less.
Yes. Oh, dude. That was funny.
Okay.
Imagining having to be aware of what you're adding or subtracting.
Okay, so let's not have division for now. Okay, we have 3 functions. We can already, if this works, we can already be okay.
Yeah, most of them we can just copy and paste, right? They're gonna be the same, actually.
No, I don't
Let's do a
know.
print. Let's just do IO garbage.
Oh,
Like,
IO
yeah,
garbage.
yeah, like just print for now. We can do write in a file later, such.
Wait.
Let's just do print.
You want to make print in Silverware,
Yeah.
right?
Yes.
Yeah. So that's, I don't know if you can, because the value here.
What do you mean we can't, dude?
Wait a sec.
I.
Oh, no, no.
Oh.
Okay, this works. Okay, this works. I have an idea. So,
Are we gonna inherit the IO from
yeah, we
Haskell?
will.
We didn't add that.
No, but we will inherit now. So we need a better
Yeah,
name.
but
We
no, but
can't use
wait, no,
show and we
but
can't use
wait. You didn't
print.
get. I think you didn't get my question. Like, are we gonna make on RST the effect type?
No, we're not gonna do
So
that.
we are not inheriting the Haskell IO,
No,
right?
but we're gonna use it now
No,
to
no,
make what
that
you
is
asked.
different. No, that's not what I mean by inherit. What I mean
Oh,
by
okay.
inherit is like just propagating the IO thing.
No, we can. I think we have the option of not doing that. Anyway, so we need a name that is not show and it's not print.
Mm-hmm.
So, wow. Oh, actually, it doesn't matter because this is gonna be just an auxiliary function. The name can be show. So let's add show here. So show will be a v-native function, and then it's gonna be the auxiliary. And what this does? This picks something showable. Are we deriving that? Oh, the value has show. Okay, so it's okay. So we're gonna pick a value and return a result of a value, exactly as we did before. And then what we're gonna do with that? we're gonna
Cry. Can
wait.
we do that?
Can we do that? Wait. Can we do that? That's the question. Because the result is an either, right? Which means that we are locked on the either monad. So, and to do print stuff,
You need to unwrap the monad.
no, not only
That is.
that. It's because in Haskell, this is the greatest difference between F sharp, OCaml, and Haskell. Like F sharp and
Mm.
OCaml, they follow what I'm gonna say right now, and Haskell doesn't. In these other languages, you have the option of switching back and forth between different monads at any time. So if you're doing in one line either stuff, the next line you can do IO stuff. In Haskell, that's not how it works. Because if you are inside a
Wait, you are
monad,
saying wait. What do you mean when you're saying that?
I mean that in F sharp and OCaml, you can have a function that is interacting with
Hmm.
multiple monads in the same function.
Well, they are different parts of the function, but
No,
yeah,
they
you
are
can.
different parts, but
Yeah, but
for,
here's the thing. Like, for example, in F sharp, you can't. You're talking about something like I don't know if I get your point, man. Because like, can't I do like let? I don't know. Imagine there is a let in Haskell
mhm.
inside a function, whatever. There is like x. There is a I don't know. Write this ABC, and then I have another thing on this let that is a x. Those are different things. That is like I don't know. Adjust.
Oh wait,
Those are
I
different
no,
things.
I think those are different things, but I'm not making myself clear. So I think that the easiest way to make myself clear is to go to Google and
Okay.
put you and show the signature of the bind.
Let me see.
Okay, so the signature of the bind, is this the one that I want? Yeah. Okay. So this is the one that I want.
Can you give me an example, like
Yeah, I
of
can give you an
something?
example. I can give you an example. It's pretty okay. So let's suppose that I pick a value here and
Uh
I do a
huh.
do, right? So from this point on,
Yeah, but
I am
this,
locked onto the either monad.
well, this in F sharp you are also locked. If you don't have a monad transformer or something.
But that's the thing in but that's the major difference is because in other languages you can do a print whatever you want. Like in whatever part of the code you want, you can just put a print. In Haskell
Oh,
you
I
can't do
see.
that.
Oh, okay, I get it. Because the print is not wrapped in a monad. It is just impurity.
Yes.
Because
That
that is the main difference. Like, for let me write in F sharp. I think it will be
but that's
like.
that's the
Let's imagine
problem. It's
there is a
because we want to
result.
do IO and the
No,
result
yeah,
is the
I get
either.
it. I get it. So like in F sharp it would be this, right? So you have like
Yeah.
let bang x that is like I don't know okay with I lost the emoji. Why do I have it here? Let
You
me see.
stopped everything because I lost the emoji.
Oh, here it is. Okay. So like this would be just x means it is just emoji. In this case, just a
Yeah.
string. But then I can do print fn like
Yeah,
this,
that's the
like
problem.
x.
Be-
Oops.
because the other languages they allow you to do the impure stuff alongside the pure stuff, and because Haskell did the impure stuff, attempted to make it pure with a type called IO, the only way to interact the either and the IO in our case is to
Yeah,
use a transformer.
I think the best way to notice this is with the do because the do basically picks a unit and it spits well, it spits a thing for the context, right? Which is in this case, I forgot the result. But anyway, but since there is a library called Aljef from a dude I was looking that it allows you to handle. So it adds this the print, for example, you can handle it. So it's like with a monad.
Ah, I see. But there is a solution to this, by the way. There is a solution, which is to use a transformer, which we already have here. I already imported to the project exactly because at some point I knew that we would want to do a print, but we would be locked into another monad, which means that
But we don't need to use the do notation, do we?
we don't need to do the do notation.
Yeah, can't we do a case with the thing, grab the thing, and then
No, we
print?
don't need to do that because the value type in on line 14, it already has implemented the show, which means that we can just do like this. We can just do this and then done.
Let me see. So we're picking the value.
Yeah, so what is this
Okay.
doing? This is picking
Okay, I
an
see,
A
see.
and picks an A that is showable. And in our case, the value we already implemented, so we know it is showable. Then this will return a string, and the print will print that string. But there's a problem, which is that this print returns an IO.
Yes.
So we need to
And you need
get,
to transform it to result.
yeah. And that's the only way that I know how to do that is to use the transformer. Because we do have a transformer exactly for this purpose. Actually, all the transformers, as far as I can
But
tell.
here's the thing. Here's the thing. This is something we want the effect, right? This is the think of the evaluator. Like we want it to just print on the screen, right?
Yeah.
Can't we just ignore and return an empty result? We can, can't we?
Uh,
Yeah.
is this correct? Let me double check.
I think so.
Okay, so we are printing and then this. Oh, by the way, I don't know if you know what this is, but this is the
No.
bind, but this is ignoring whatever the hell is going like.
No. Mm-hmm.
Yeah, because on the normal bind, this will return the result of
Yeah,
this
I
thing,
see.
right? But we want to ignore that, so we do like that.
Yeah, yeah. So I think that's it, man.
And then just write vunit. Yeah,
Yeah,
that works.
that's literally signature in like Okamo F sharp.
Yeah, but we lost the possibility of returning a
Ah, who
left.
cares? That's just autism.
That's-
So let's do it here. So auxiliary, it is show. Okay, I we can keep show, I guess. So okay, we have these examples. That's more than enough. Let's try
That's
to
more than
test them.
enough. Okay, so let's go to examples and let's create. I don't know.
Let me follow you.
Yeah, so new file. So let's put, I don't know, show.sw. So let's try to parse a show shoe. Um, as far as I can tell, this should be classified parsed as a variable, and this should be parsed as a literal.
Actually, as an application, which the first expression is a variable and the second is a literal.
As an application, you're correct. But then I have a question. When the hell we are gonna have the? Oh, we do line 35. Oh, I see.
Oh, we added that. Yes.
I'm surprised.
Yeah, and you're surprised as well.
Okay, but before doing that, I want to add proper, because you're gonna get confused pretty fast. So let's add the error messages properly.
I have a strong feeling that the currying will not work.
I have a very similar feeling, I would say. So we need to unpack. Need to pack. Okay, so we're gonna do can't operate this on no numbers. And then we do pack. And here we're gonna do wait, we don't have the name, bro. That's bad.
We don't
Uh,
have the name.
yeah, because I want to tell the user a proper error message, but I don't know which function he provided. Like the OP doesn't have a name. You see, I cannot print this because this is a function. So the only way that I know how to solve is to pick the name of the map and also put that as the name, which is ridiculously stupid. and I don't want to do that. But I don't think we have a choice. So let's add that. So this is going to be the name. And then I need to do show unpack and then name. Yeah, I guess so. Can only operate this. Can only operate with operation this. And then we do the same. Like that. And then we do like this. Because of our... And I'm probably forgetting a printf somewhere. Oh yeah. So printf... Yeah. And this is the same thing in here. But instead of rationals... Oops. We put integers. Okay. This works.
Right?
Which means that now we need to add the plus, the minus, and times. Okay, and I don't have an option of failing to print, which is...
Yes. There's no possibility of that failing. What do you see there? I
Okay,
don't
so
know.
let's go to the main.hs file now. So what do we need? We need to read a file, which is very fine because we can just do content, read file, examples, show.
People who literally think that can fail are paranoid, man. Yeah. Why are they laughing, man?
uh, People that think that the print can fail are paranoids. Okay, so
They have a
now
better explanation. I don't.
let's go to the parsec library and remember how we parse stuff, how we call our parsers. Because I already don't remember. Oh, there is a thing. Uh, what is source name? It is a string. Is this the name of the file? That would be really cool if it is. Because then we don't have to read ourselves. The parser already reads.
Oh, that's cool. I don't think it is, but let's see.
What is S, by the way? There's a function called parse from file. What the hell? I need to discover what is S. So the most general way to run a parser. Run parser t, p state file path input, runs parser p on the input, list of tokens input, which is this, obtain from source file path with the initial state user state st. Okay, the file path is only used in error messages, maybe the empty string. I still don't know what is this, which is not great. Where is the run? Token. Okay. So I think we're gonna have to uncover what is this S, because I think that this is the parser. I think that
State?
this is, I don't know what this is actually.
No idea.
This is the source name, which is the file path to the file that we want to parse.
So string s
And then
identity.
we have this.
Dude, why are they exposing this much shit, man? I don't understand
Because
it.
this library is much more powerful than what we need. That's why.
I don't know about powerful. Well, probably it is, but
Oh, here, parse.
exposing this sort of shit, man, it's
Wait,
just.
but there is a thing called parse, which there is an example. So you pick, there is a number parsers, which is comma separated by integers, which is, man, this is so readable. I love this. Then you parse the parser. I think this is the initial state, and I think this is the no, this is the source name. And then S. I think wait. Runs a parser P over identity without user state. We don't want a user state, so this is what we want. The function that we want is parse, which is good. Then S. I want to know if we can't not pass this. Let's try. Instead of just speculate, let's try. So what we want to do, import text parsec, and we want the parse function. Is that correct? No, it's text parsec. Yeah. So we're gonna have to do a return here because this return is a neither as far as I can tell. Yeah, this return is a neither. And this needs to be an IO. So this is gonna be parse. Then we pass the parser, which is gonna be expression P, I guess. The source, and I'm gonna put empty in here. And I don't know what's gonna happen. Okay, thanks HLint. Content. Okay. Do I have the type of this? No, I don't, because my LSP is broken. Do you have the type of this?
No.
Cool. Okay, so now if case of content, potential content, because this can be an error. If this is a left with an error message, we just print with this, right? So error parse. I'm actually gonna put better names. Okay, but if this is okay, then we have an AST here. What should we do with an AST? We should type check. So we're gonna do like that, like this, right? Then we're gonna type check this AST. If the AST returns an error, this is gonna be an error of typing. So error type. Then, if this is actually correct, we're gonna have a write. We're gonna ignore because this is the type of the expression. We don't care about that. Then you're gonna pick the same AST, call eval, erro evaluator, like that. But if it's correct, we're gonna just print the result. Okay.
Awesome.
Okay. Now one final thing. The evaluator needs to have a. Oh man, we need to make the other context. We forgot.
The other context. Oh, right. To edit there, right?
Yeah, we need to add another map for the. We need to create the type checking and the kind checking. So here. So we're gonna have a typer prelude. Because then we're not gonna have stuff. And this is the kinder. Oops.
Oh man, looks like you're speaking German.
Okay, but then there's a problem though, because the evaluator only requires, we need to import prelude here, which is okay. And then instead of map empty, we're gonna put evaluator prelude. Okay, the evaluator is not fulfilled with our for functions. We need to do the same stuff for the typer, because if you go to the typer.hs and you go to line 112, you're gonna see that we also have empty maps here, which means that we need to change those. The ones that we want is the variable types. Yeah, variable types. So what is the type? What is the type of plus, plus, times, and stuff? So let's think about that. It's an arrow, right?
Yeah.
Okay. So what we need to do is to go. Okay. So U needs to be a type, and you're gonna be a T arrow. Types. It is a T arrow that goes from a type to a type. We have a problem.
Which is?
We have a gigantic problem actually, which is that the plus can only have one type.
Oh, dude. Okay, I thought of that, and I had a solution in my head. Just a second. Let me think.
uh, the things can only have one single type, which basically
Yeah.
we're gonna drop into the OCaml ocean pretty quickly.
Yeah. Okay, but can we do the show first?
Yeah, we can. So the show is easy.
Okay, motion. No man.
The show is easy. It's T unit.
Just a second.
Oh, this is so sad.
Okay. Yeah, man. This polymorphic shit. Like, what are we doing? Like,
I don't know if you have a choice, man.
it's
Or
just a waste of time, man. What are we doing?
it's not a waste of time.
It is.
No, man, it's not. I'm kinda. Oh man, but if we do this, it's gonna be so hellish because everything else is gonna be wrong automatically. I'm kinda in the wanting to make like a T number type, which has two possible options. Because the issue is that we have
Okay.
them separate, right? We have T integer and T rational separately. And that's why we cannot have polymorphism, because we can only have an arrow from one specific type to another.
Yes.
And
We
but
could do on the type checking. I think. Oh, okay, dude. I think I was. That was the thing I thought. We know part of the arrow, right? Actually, fully we know the arrow, right? So what do I mean with this? We know that in this function in specific, we can receive a type. So what is the type of plus? It is a for all, right?
it is a for all.
For all number in this case.
Oh,
That's
okay, I see what you
yeah.
mean.
And then, like in this case, we know what is the abstraction of the type we want, which is I don't know, an integer to integer, right? Oh, sorry, integer to integer to integer,
Yeah,
right?
yeah.
So we we can check the type because we will know what is the first type or the first element, and the other one being separate. That's also not a problem because we let me see. Yeah, that's also not a problem because we have this E application uh, atop of the type, atop of the expression, right? This E application.
No, but I am.
What is the
I,
type of plus in Haskell, by the way? Can you
it
show
is
me?
an A to an A to an A in which A is a num.
Okay, no, because of type classes.
Yeah, because it has a type class for all the numbers. Well, not all of them, but the useful ones. And that was kind of my suggestion. My suggestion was kind of making the poor man's version of type classes because we would have a new type called tnum or tnumber, and then we can have t integer and t rational being some type of that. But you said
That's
something
more.
really interesting, which is that the plus is a for all.
No, it's not really. It's identity is a for all because for all is for everything, right? It's not really a for all.
Oh yeah,
I
no, it's
just
not a for
I
all. It's
just
not a for all.
implied a for all because it is a escape hatch. I think we could exploit, which is
There is
you have the
something other
type.
thing that we can use to like to get around this problem, which is to not type check.
That's pretty bad, man.
No, it is pretty bad, but at this moment we don't even know if it works, the evaluation, right? This is the first time we are trying to see if the pipeline works, and we encountered a problem with the types because we don't have polymorphism, which means that, uh, well, actually, I think that for the sake of testing, we could just make the plus and the multiplication for integers, and who cares? Who cares?
Yes, I agree.
Yeah, so
And
this is
then we
gonna
do,
be.
and then we fall in the Okamo.
Yeah, no, I don't want that.
What do you mean, man? Yeah, makes sense. So it is an arrow that takes an integer and leads to another arrow with an integer with an integer.
Yeah, okay. And then we can have the same thing for the other two. Which is this and this.
Mhm.
Uh, which is okay. And now we go to the typer.
And the show is also wrong, right? We take something that is showable, which can be anything, so that could be a for all. We take some garbage and then we
Wait,
print.
you said something. So you said that the show is not type T unit. Oh yeah, it needs to
No,
pick
that's the
something. Yeah,
result. Yes.
yeah, but it is another arrow.
Yes, it is a T arrow, but that's what I'm questioning. It should be, in theory,
For
or a
all.
string, or a for all.
Yeah, it can't be a for all, I guess. Well, it can be a for all, but then we are not being safe boys
Yeah,
because
we're not doing a mask and whatever. The thing needs to be showable, but
yeah.
yeah.
uh, well,
Just do a string, man. Oh, we don't have the type string.
we don't have strings, man.
Damn. Oh, so just do a for all, man.
Yeah, I think we don't have a choice. Okay, so how do we do for hours again? Let me remember.
I don't recall as well. It's T for all, and then there's T for all info
Yeah, but
inside.
how we... The T4 info picks a text, a kind, and a type. So... A text, a kind, and a type. Okay,
Text is the label of the thing.
text
The
is the
kind
label,
is
the
the
kind of...
star in this case.
Yeah, and the type is T-unit, right?
Mm-hmm.
Yeah, okay, so let's do that. So this is gonna be a T for all with a T for all info. And then here, I don't know, whatever label, star K T unit. Is that it?
Yeah, I guess so.
Should this be A?
Yeah, it doesn't matter. It's a label. But then you gotta do a T variable of that thing, right? Which is the arrow of this garbage.
No. But that's the problem. Our show, actually not even our show. The show of Haskell is this. Wait, actually, it's not the show of Haskell.
Pick identity, man. Identity is better.
Show
Look at
A, and then this, and then IO. This is what we want. So, but
yeah.
we,
The A would be the T, the
yeah, exactly.
abstract, the T, the type variable.
The
But
T,
that's the thing. It should be a function that takes this type variable to unit.
it should be a function that takes this type of variable to unit. Can you refresh my memory of what is the type of the T4O info?
Isn't it the type that it's shadowing over? Like, okay, I'm applying the variable that I have on this text, which will add to the type context. See what I mean?
Maybe Maybe it
and
is
then
that.
there will be an arrow of the t variable. I don't know, a in that case, to unit.
Maybe it is that, but I really don't remember anymore. So let's check the kind checking. So when you type kind check at T for all, you pick the identifier and you put with that kind into the environment.
Mm-hmm.
Then you kind check. Oh no, I think that the type. It is the body, right, of the for all.
Yes, it's. Oh, we changed that name, man. Why is it with the old one?
No, we changed in another place.
Oh, okay.
And then if the body is, we can check the with the new environment this type of the body, and this is gonna be body. And if it's a star, for all should return star, but this has something else. Yeah, so the type, it is the type of the body, which means that it is the unit, man. Don't it isn't it? Because the body is a
No,
print.
no, dude. It is that is the result. We don't want that. What do you do with a for all, by the way? What is the purpose of it? It's to cast another type, to introduce a variable inside the type,
Yeah.
right?
Oh, this
So
is the
what
body
is
of
the
the for
type?
all. Oh, I'm
Yes.
so dumb.
So that should be the t arrow with taking the t variable t to unit.
Correct. I agree.
All right.
Okay.
Now, how are you gonna make that run? It's
Wait,
another
no, wait, we're
question.
still not done. We need to go to the typer and add that. So which one of those is I think is the first. Yeah, variable types. It is the first. Then we need to do the kind context, which is the second one. I think the kind context is gonna be pretty easy. Type, typer, prelude. Yeah. And then here, the kinder prelude is easy because I think everything is a star. So star
Mm-hmm.
K. This is a text to a map, right? Let me double check that.
Yes, it is a
It is a
text.
text to a kind. Okay, cool. Let me also check the
Which are
type.
kind?
Yeah,
Kinder prelude. Why a kind?
because we need to check. Let me go back to the typer here. We have something called kind context in which you map a label to a kind.
Why the kind? That's the typer garbage.
No, but we
Wait,
need that to
what
the
are you looking?
kind.
Sorry, I think I missed. What are you looking at?
I was looking into the typer.hs line 22.
Okay.
So there is something called kind context,
Yes.
which has a map that maps a label to a kind.
Yeah. Okay. I thought you were talking about the prelude thing,
No, but
which
we
is
are,
different.
but not this one. We are talking about the third one, which is that the
Oh,
label.
the kind. Okay, the prelude for the kinds of this garbage.
Yeah,
Okay.
I think all of them are Starcade.
Yes. Actually, the last one is not right.
Oh, their last one has a for all.
But it's not an abstraction, so I think it's still star.
But it is not an abstraction. What do you mean by it is not an abstraction?
Like it is only if it is the type T abstraction, right? That is it is that thing. Check the kind check.
Check the kind check.
What happens if it is a for all garbage?
What happens is that we pick.
T application there. What happens if it is a T application? Then that is we just check.
We check. No,
Oh no! Well, it needs to be an arrow. It needs to be an arrow that is, and then we do if the kind of the argument of the first argument is the same as the first argument of the function is the same
yes.
as the argument of the thing that you're passing, then
Yeah.
you just return the second.
Yeah.
Otherwise, it fails.
Yeah, but are we doing an application there with the show? That's what I am, because in my mind we're doing a T for all.
Yes, which is a T application at the type level, right? Oh no, we're not. I'm confused, man. I'm sorry. No, it is not. That is right.
Okay, so
It
if
is
it's a T
the
for
T for
all,
all is something apart. So
it,
that is just a
the
star. So that is just a star.
yeah,
Where
we
is
add
it?
the identifier with the. It is here, line 131.
Oh, okay.
So you add the identifier with
Yes,
the kind
star.
context, then you kind check the body to see if everything is alright, and the return of this needs to be a star,
Mhm.
which I assume that this is what should be in the prelude as well, star. Star K. And then we go here and we add the kinder prelude. Okay. Okay. So now, moment of truth. And
Quack, 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 quack.
attempting to use.
Main prelude, which is not loaded.
Wait, but where are the error messages? I
Well,
am very confused right
it's
now.
just the last one, right? Attempting to use, but it is not loaded. That's
Yeah, but that doesn't make sense.
Did stack add the thing?
I do have stack, right?
No, but did stack add the garbage?
Wait, yeah. I don't know, man. Let me double check that. Module. We also have the modules here. Module types where. Module prelude where. Oh, maybe prelude is not a good. Maybe prelude is a bad name.
Oh.
Let's call S prelude for Silverware. SW prelude.
Okay.
So let's rename that. Maybe that's not the problem, but I just want to be sure. And I need that to the typer as well. That was the problem.
Okay, now it's the garbage.
Okay. So now it is complaining about stuff. Unexpected do block in function application. In function application. Wait. Wait, some native? We don't even have some native anymore. What happened? Some? No, not
No
there.
one knows what is
Some native.
to be a sad man. To be a blue.
Arithmetic native. Okay. Yeah, that madness that I had with calling the thing again didn't work. We're gonna have to copy paste. I'm so sad right now. Unexpected case expression in function application. Unexpected. All the errors are happening. Yeah, all the errors are happening in the SW prelude. Yeah, so something about what we did here in the arithmetic native is wrong. Which makes sense because I was very uncomfortable with this function.
Oh, that still makes me very uncomfortable. I wasn't. I still am.
Very, very uncomfortable. Oh wait, we need to pass the name here as well. I don't know if that's gonna help, but I just want to try. And yeah, didn't change anything. You could write it in parentheses. Yeah, we do need to do what you said, but then I don't know how we're gonna not copy paste a bunch of code.
Wait,
Man.
about what I said on one.
Yeah, because this arithmetic function calling itself.
Oh yeah.
Uh,
Just copy paste, man.
but
Don't
man,
think.
copy
Make it
paste.
work and then we think.
make it work, then we
No,
think.
seriously, like just focus on making it compile work, and then we see if it's correct, and then we try to see patterns if we can tree.
Okay, I guess.
It's garbage, yes, but
It's garbage. Okay, so help me out. So how can we make this work properly? How can we make this work properly?
okay. So first of all, can we do just a the easiest, dumbest way would be just making. You know what? What I'm very uncomfortable with is with the parser. How will the parser generate this?
It should generate. Well, we can test that without fixing this problem.
Can we do just a plus that adds to 1?
Yeah, I don't
Let's
think.
do that, man. Let's do that. Comment this part of code. Don't delete. Just comment. And just
Okay.
make arithmetic native that does the same operations as you're passing there, but with 1. So
The
the
same
second sheet,
operations, but with one.
yeah, the same thing. Like you do, like plus, multiplication, division,
Oh, but
less.
with the number one instead of
Yes, but
asking for the
instead of
second.
yes, exactly. Instead
Uh,
of asking for the second, you just do 1. But then you
oh,
need
that's
to
gonna be
change the
so much
type.
easier then. Okay. Um, uh,
So just delete these.
I
The
think then
second,
it's gonna be just
yeah, you just do
first
right
plus one.
first plus 1. Yes.
Well, not this. This.
Yes, OP first one.
And also write OP first one.
That's it.
And everything else don't care.
Burns.
Okay.
Yeah, but we need to change the type signature, I
Not
guess.
in scope. Eval env. Eval. Oh, it's
Evolving.
because it's used in here. Okay. So I'm stealing you from here. You now live here.
Okay,
Congrats.
your new home. I do think the types will break.
Okay, now we have a lot more type
Mm.
issues. Okay, let's go. Oh, this is the print one. So let's fucking go.
Mhm.
So
Okay, so
so
these.
it is expecting a list of values for some random crappy reason.
Okay, right value. What?
Line 54. Yeah, this. Why is this thing expecting uh,
And this
a list?
expected list of value, but the actual type is an either with some guard.
Yeah.
Oh, the print I think takes a list, right? Oh, that
No,
sucks.
the print doesn't. The print takes a list. What?
Oh, it
No,
could be. No, that's not.
that's not it. Okay, but now, well, this is probably HLint complaining about the parentheses. I just want to make sure that we're not using the wrong stuff. Okay, okay, the parentheses helped. Cool. So,
Expected type IO value, but actual type either. So can't we ignore the monad?
yeah, and so I was correct. So once you enter a monad,
No, dude, that sucks. Dude, you can't ignore it. Oh, man.
no, but that's the thing. That's the because everybody, not everybody
Yeah,
else, but the other languages they are used to the
I get
Nutella
it.
version of not having side effects loosely defined,
Yeah.
and then because of that you guys can do awesome stuff like prints whatever you want.
Awesome stuff.
Yeah,
Awesome
because I
stuff.
consider debugging with prints awesome. I don't know about you.
Yeah.
But here, because we are restricting the side effects to a type, once you enter it,
Yeah. It's
that's what I was
over.
trying to explain earlier. When you have, oh man, I lost it.
Can't we
Oh,
do
here.
wait. But
Go.
can't we do a trick?
Well, tell me the
We
trick.
do another function we unwrap the IO inside that other function, and then that function returns a unit.
Wait.
We cannot do this, right? We need to propagate the IO.
Yeah, I told
Ah,
this
that's
I told this to
so
Breno
bad.
once when I was beginning in the Haskell world. I told him, man, when you introduce IO, it pollutes everything else. And then he said, yeah.
Yeah, that's okay.
and
How do we?
that's that's why transformers are so damn useful. So
Yes,
either
I totally see now. Yeah,
either
because I
T
never saw really the need of the well, especially on the IO, right? It's pretty unnecessary in
No, but that's the
abstract.
thing. The transformers, as far as I can tell, the main purpose of the creation of the transformers is because of the existence of the IO. Is because
Yeah.
everybody noticed that, oh man, we cannot do programs for like industry stuff if we don't have IO. So we need a way to have the effects of the modules that we want, but we want to do able to do IO. And then, oh,
Mm-hmm.
that's where the transformers come in. So we have, for instance, the transformer either t, right, which interacts the either with another monad of your choice. It can be a maybe, it can be, I don't know, an except, but in the majority of the cases, at least in my experience, you use this to do IO stuff.
Okay, I see. All right, let's use that crap then. Is that a library or is that like on?
It's on the either stuff. So let's see if I have added this. Actually, before doing that, let's go to package and go to the transformers package because that's the one that I added. So transformers. Transforms.
Mm-hmm.
Okay. So
Okay, I see.
we have a lot of them. Let's see if the either is in here, and
You
it's not
have
great.
lazy and strict stuff.
Yeah. So this is a combo monad. This is the reader, the writer, and the state.
Writer and the state. Uh-huh.
So you can read configuration stuff, you can write
Wait,
logs, and you
what
have a
is
state
the
machine.
wait? What is the expect? Except. Sorry.
This is the evil either brother.
It,
Because some
that launches an exception. Is that it?
no, it is an either.
Extends a monad with the ability to throw exceptions. Oh, that's very useful. That is like there's a library. Not sure if you don't have this problem. There's a library that's actually. I don't know why you would want this though.
Well, because if you
Yeah.
want to throw exceptions, you can, right? We already
Oh.
discussed about like exceptions have their
No.
space.
Yes, they have the space, but why would you want
Oh, you see
there?
here? This is exactly the same stuff as the either t.
I
Either
see. See.
running. Yeah, so the accept, as far as I can tell, it is the another way of expressing either, but it has this exception stuff that I am not really. I never used it, so I don't know how to use.
Mm-hmm.
Uh, but for our purposes, oh, it's because I can use this and this. There's a handle, there's a try, a finally. Yeah, so this is the main difference then between the either t and the accept t is because the accept t you can use these functions to throw, catch, try, and etc. But I don't need that. We just want to do a simple IO stuff, so I think that the either would be enough. So let's go here. Let's go to our packages. Let's add either. Um, then, if you go to the prelude, then you're going to be able to import now. Import control monad trans either.
Just a second.
Okay.
Damn it, Zio. I didn't notice the problem. Now it
Yeah,
makes
yeah, but
sense.
that's I don't know how to explain it yet because this is very new territory to me as well. But I knew that, oh man, when you enter stuff with IO or any other one, especially when you're using do notation and bind operators, which we are using one version of the binds.
Yeah, you know was astonished, and I don't know. I still don't. It's not clear to me. It is the part of the bind with the ignore because we're not executing that part per se. Like it's just wrapped in there in the IO, but we're not doing anything with it. So why is that thing?
It is because of the type signature, man. Because the type signature of this guy expects that the right part has an IO.
No, but what is the signature of the bind in that case?
Okay, so let's do it then. So let's ask what is the type signature of this, right?
It takes a monad.
Yeah, M. Okay, so whatever
A.
is happening here,
It is
M
the
is.
same monad. Oh, that sucks. Okay, I understand. It is the same monad. Oh, dude, that we're stupid. Like a bind, of course, it's the same monad.
Yeah, no, but that's the thing. I can't take that. The reason I didn't force it is because I'm not sure about that because I am well, like I said, this is very new to me. I used very few transformers. So anyway, I just had the feeling of it, and that for me was enough. Uh,
Dude,
okay,
you know
so
what I like on F sharp? These things are so much clearer to me in the computation expressions, man. Like for example, the applicatives. I could only understand properly when I saw the end and bang. Like that made it a lot easier.
no, I understand that you learn things better in a language that you're more comfortable with, and if computation expressions F sharp help you with that, that's fine. I understood everything that I know of functional programming in Haskell, so uh, that's why I prefer this way. But I just don't need to remember how to use it though.
No, I'm
So
just saying like because I think they it's really a rare situation. Like it's partially I also feel uncomfortable in Haskell. There's that, but I
mhm.
think that's a bad because F sharp looks way more procedural, like ML in general. I know it, and I think it's just because of the lets they give that impression that you're doing procedural stuff
Yeah, I agree.
when it's just a letting with like scopes wrapped. But
Mhm.
anyway, dude, I need to go have dinner. Can we pause?
Yeah, we can. So I
Okay, I'll
will
be back in like
pause.
10 minutes or 15. I don't know.
Okay.
I'll be back really quick.
Okay. I managed to include a library, and I discovered that the either T unfortunately got duplicated, and now we are kind of forced to use the
Oh
accept
no,
T.
you're kidding me. You're
Yeah,
kidding me.
no, we need to use. It is the same stuff. It's just a different name. I just prefer either T instead of accept T because of the name. But anyway, uh, so what I did, right? What I did. Wait. So now it's complaining that variable not in scope. We don't have this lift.io, but I think it's because I am messing around with the way that I'm writing this stuff. So I think this needs to be an IO, and then this needs to be an either of a text and a value. I'm gonna explain shortly what lift.io. Well, I'm gonna try to explain what lift.io does. Okay. Yeah. So in the second, namely this. So it's expected to have the kind star to star, but this has only
Dude, just a sec.
star. Cool. How cool. Yeah, so the previous version was correct. So this is text, this is value. And it has the monad IO type class. It also has the monad fixed type class, which is interesting. Oh, it's here. It needs to receive an IO A, an IO for value, an IO for value. What if we do that? Variable not in scope, what do you mean, brother? So it is an export issue. Okay. Okay. So now we can go back. Okay, so now I need to go to this. Okay, so instead of doing write, I'm just gonna return. It worked. Holy
Okay, I'm back.
bananas.
Did it work?
Yeah. Wow. Okay. Okay, so let me attempt to explain
Okay,
this
that's
shit.
a small step.
Okay, so this is the final implementation.
Mm.
Okay. Okay, so let's first start with the signature of this guy. So it's in acceptee, text, IO, and value. So let's go back to the documentation. Because without this documentation, I would never understand what's happening at all. So when you create an acceptee, you have an E, an M, and A. The M in the middle is the monad that you want to interact with the either. The A and the E are parts of the either. So in our case, the E needs to be a text because our either is a text to a value, A is a value, and M in our case is IO because we want to
Mm-hmm.
interact with IO. And that's the first, right? So whatever we do, we need to return uh, this guy. We pick the value, then we make it we transform it to a string, then we print, and then this thing has the type IO. But there's a
Mm-hmm.
problem, right? We are in the middle of a do block of the except. How
And
do we
then we
solve that?
do.
We call a function called liftIO. What liftIO does? It does a very special thing, which is this,
Okay.
which is exactly what we want. Because why? Because that do notation, it is the notation of the monad acceptee. But we
Look for
want
the annotation of the unsafe perform IO, by the way. I just want to check.
uh,
Okay, we could have used that.
no, well, we could, but this is bad. This
Anyway.
is actually like using the transformers is very safe in comparison.
Mm-hmm.
Anyway,
Well,
so
it's probably using unsafe perform IO
well, we
as
can
well.
check. And okay, so it has a requirement to instantiate the acceptee of the monad IO for acceptee. The inner monad needs to also be a monad IO. In our case, the M is an IO, so we would have to check how lift IO is done for IO itself. We can check that. So if you could click on that, no, not that. Oh, here. Yeah. So now let's enter the source code of that. Um,
It
it's
would be pretty
ID.
funny if it. Oh, okay, okay. It would be funny if it were just an alias, to unsafe perform IO. That would be very funny. Oh no, because we do mono transformers here and it gets all safe and it's just unsafe for.
No, but I can guarantee you that at some point, when you interact with IO, at some point unsafe perform IO will be called because this is a quote from my boss. We need to interact with Earth, which is impure by nature.
Mm-hmm.
So we need to pick our poison. At some point, we need to open the gate of hell, and people decided to open it with unsafe perform IO.
That
Uh,
that sounds very drastic, but like that's the standard for most languages. Anyway,
Okay, so what you need to know. So we are doing IO stuff, but we are still on the accept monad because we are lifting. This is actually pretty important to have this notion. It's you need to imagine the IO in one single plane of existence, and the lift IO function is lifting
I
this
know
IO
what
to
you
this
know
other
here.
monad that is on top.
Hmm.
Because there is
I
another
know.
guy called unlift IO.
Yeah, I know the analogy you repeat. That's the same on the what's the name of the thing? Category books, category theory for programmers. The Bartosz Milowski thing.
Oh,
He
okay.
uses the same uh, sayings like lift, such.
hmm
I prefer to just do unwrap, wrap. I know it's wrong, but I
Okay,
like
but
to
there is
think
a
of it as
problem
a
though.
present,
There is a fundamental problem that we didn't anticipate,
which
which is
is
that we need to get rid of the except t at some point. We need.
yes.
The usual way of doing that is to call the run function of the transformer. All transformers has this function. We
Hmm.
have the run maybe t, run state t, etc., etc. But the issue is that we are still kind of locked on the previous mono that we did.
Hmm. So
So,
that's back to nothing.
no, it's not back to nothing because if we manage to make a do notation, we can get rid of this guy, I guess.
Wait, isn't a do notation gonna spit the same dude? Like if you
Yeah,
do peer blah blah blah, it will wrap this in, will wrap the blah 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 into this garbage, right?
it will wrap. No, no, no. Let me explain. This that we just did, this function auxiliary, it ends with an except t, which means that if we
That
call
the
run,
result will be accept, right?
no, the result will be accept, but that means that if you call run except t dollar, if you do this, run except t dollar, and then auxiliary something, this has the type, IO either text value. Because the run except t, it is picking the transformer and kind of unwrapping, right? It's kind of like undoing the madness into two different portions, right? I think it's actually easier to understand with this example right here. So look at this. This is the state transformer. So the
Hmm.
state is a list. The other monad that you want to interact with is the IO. This guy you can ignore for now. I can explain later what this does. So look at the main function. This main function needs to return an IO. So
Okay.
we're gonna call run state t. Then you pass the thing that ends with state t, and you
Hmm.
pass the initial state also. Then this guy will return what? This needs to return an IO of something. This. Because then the guy is doing a bind, ignoring the output of this thing, and just returning the IO of unit, which is the expected type of this. And if you take a look on the state machine that this guy is using, it's pretty simple, right? He's picking from the list. No, not from the list, sorry. He is pop. I think this is removing stuff from this state. Yeah. So he's picking things from the state, which is pretty like mind bending because you're looking at this function pop and it's popping from what, right?
Yes.
That's when you
Okay,
evolve.
that dude, that's the same. That's the same shit I see. Oh man, let me find it here. It's from the same guy I saw. Same
Oh no, no,
example
no,
he
the
made.
pop is here, man. The pop is not created, is not default. So the pop picks. Oh, the get is by
Yeah, I
default.
know, I know. It's the same shit as I saw here. The state monad F sharp. Let me show you. State monad. Let me see. Yes,
No,
Brian
but look at this,
Burns.
man. Do
This
you see?
dude.
He's doing state stuff, but he's also printing stuff.
Yeah, I see.
And the
Hmm.
IO function that he created is lift IO. But
Oh, by the way, take a look at the example. It's the same code, man. It's well, but without the IO garbage because you don't have it.
uh, I will take a look later, but I am concerned now because I think this means that we cannot get rid of the impurity. We need to manage the I/O at some point.
I mean, let's just do unsafe perform IO, man. I just want to print something, dude. What the heck? Why so much suffering levels? I literally just want to print.
This is the
You don't,
conclusion.
yeah,
The
dude.
conclusion.
You don't
Let-
understand me. I just want to print.
Okay then. If you want to do that, that's gonna be pretty sad, but and probably we are doing it wrong, but okay.
Oh, we are certainly doing wrong, but the thing is, do we matter? Do
Do
we
we
matter?
care?
Do we? Yes, do we matter? Probably not as well. But anyway,
Okay, so we're gonna do like that. Oh boy. We're gonna do. Oh man, I feel dirty, so dirty. Print uh, show of a value, then then we need to apply unsafe perform IO to the scrap.
I'm loving this code already.
And
Ignore.
yeah, we need an ignore. We do need that.
Can you have a bunch of like code like I don't know how this works in Haskell. I know in F sharp, but how does it work when you have an expression that returns unit? And how can you chain more expressions?
Yeah, usually we do this. Yeah, usually we do
But isn't
this.
that for moments?
Um,
Hmm.
well, the only change that I know is to do composition, dollar, and bind. I
Because it's weird to use the bind in that case.
No, I
Because you
agree
don't
that
have
it's
a.
weird because unsafe perform IO is picking the IO because this is now an IO, right?
Mhm.
Uh oh,
It's like I'm asking like an implicit program, like that. Because the print will return an IO wrapped on unit, I guess.
yeah, it's gonna be IO unit, IO unit.
Yeah.
But then we're gonna unwrap the IO to have the unit, right?
Mm-hmm.
So now we want to what do we want to do with this unit stuff? We want to just ignore it. I never had to do this before. Ignore. Um, we want to pick this A, ignore, and just return right V unit. We want to return right V unit. How can we do that?
I think it's something so unnatural to do in Haskell actually.
It's so unnatural. No, but we have a way. We can do this. Uh, let whatever this, and then return V unit. Yeah, this works. I guess. I
You
never did
guess
this in my life, so
everything is uncertain here.
yeah, it worked.
Okay, now we just have other. There's a signature we need to.
Oh, we crossed the line. Arithmetic native is wrong. What is wrong? Oh,
Yeah, okay, that's what I wanted to know. But yeah, it is the same thing in Okomo F sharp, right? It is not an implicit ignore in that case. You need to do the capture of the thing.
yeah. Okay. Couldn't match expected type A with type integer. You know what? I don't care about this anymore. So let's just ignore this. If this
Oh,
has a
okay, the type.
problem, we're just gonna, I don't know.
Oh, dude, that will be so painful. Okay, but it will not be painful if we wrap the
Okay.
thing in a val. No, no, no. The problem we're not wrapping, right?
Wait, what is the problem?
That's why the problem. Why is it complaining? It is complaining because the result of this is not a value. It is an integer or a rational. So there is this disparity. That's the problem. Like,
Um,
go back. I'll show you the issue. So it's like, yeah. Oh man. Okay. So what is the first branch? The 50.
the
That's an
50
integer.
is if it's an integer.
It's an integer
Oh, we do
inside
need
the
another case here.
either. Yeah, we do, but it's an integer inside the either, right? The second is not an integer. See the issue?
Oh,
So
so it
just
should
wrap
be
this
like
garbage. No,
this.
yes, that, but just wrap. You forgot to wrap this garbage into a value, right? So v literal
Oh,
and
that's
then
correct. That's
l
correct. That's
rational.
correct. We need to add it back to v literal.
Yes.
So it's gonna be v literal. This. I think we can actually do like that for this case. So v literal. But there's another issue though,
You
which
need to
is
wrap in the
that
rational as well. The L rational and L in.
do we
Yes.
L rational? There's another issue,
Hmm.
integer, which is that when you do this, you are kind of adding boundaries to this.
Yeah, but that's not an issue, right? It shouldn't even be that to begin with.
No, it shouldn't, but we want it to be just for the sake of testing. So, uh, I'm so surprised this worked.
I don't know, man. I don't know what you're talking about. It worked.
Yeah, but we are doing it wrong. We definitely should do a transformer here. Uh,
So what is the saying that I would say in this situation like this? Nathan would totally get the right time. We can do it later.
yeah, you see that the A is actual type integer because we are saying it is. Oh, actually, two things are saying that, right? Because the L integer always grabs, like, stores an integer, so this is also an integer. So the OP cannot be this anymore, um, which sucks. I think that the right way for us is to just ignore this for now. Uh, and then later we can think on a better way of doing it. The title of today will be "We Crossed the Line." We crossed the goddamn line. Okay, now we have just problems with the kind stuff and type stuff, I guess. Nope. So what are you complaining, my man? Line 28. 28, it is this. Well, this is a function. Oh, it's because, wait, is it what I'm imagining? Couldn't match expected type? What the heck is this? Um, we have a function, we have a text, which is a name, and we have a value. And we want to partial apply, right? No, not partial apply. We want to send these two things first, the function and the text. Yeah. This error message is not helpful. This thing is not helpful at all. The function this is applied to three arguments. The function. Oh, the commas.
Oh, okay, that was pretty stupid. Probably the same thing on the
Probably the
star.
same.
Yes. Oh, man.
And okay,
Oh,
this is
they
better.
never stop. The errors never stop.
Okay, so the evaluator now is now complaining. So evaluator.
Okay, it's probably just imports because you moved the file.
No, but I am. It's saying that the
Import
import prelude.
prelude
We don't have
value.
prelude anymore. Oh, it's here. Good. Next. Okay. So. Okay, so this is a sign that we need overloaded strings. Or we need to a type annotation. I think the type annotation will serve us okay. Yeah. So this is a map, the text and picks
Mm-hmm.
values. This is one that picks text and returns types. This is the one that picks text and picks kinds. Cool. Verb not in scope, expression P. Now we are talking. So this guy. So we need, what do we need? The parser needs to return for us stuff. Okay, so just import parser. Import parser.
Mm-hmm. Yeah, I think that
Okay, almost there. Error parse. We need to
could
import that
match.
from this.
Okay. Curibilamos.
No. Uh,
Port text, they didn't even.
no, wait. Error parse. This is coming from here.
Yeah, this is a label. This is not a.
This is not a
This is a value,
function,
right?
so I
Yeah.
am really confused right now.
What is it complaining? It's complaining on
Couldn't match. Okay.
data text, internal text with a text per sec.
Error dot parser error. So we need to check what is the either that is returning from the parsec. So when you call that, it calls a parser error, which has a show. Okay, so I'm just gonna call show. I don't care. So show.
See.
No. Error parse. Okay, what is the complaining now?
Let me see. You're packing, right?
Oh, we need to pack. Okay,
Oh,
good.
you are packing.
No, we are not packing.
Oh, you're packing the one before, right? Just appending. Yes.
Ah!
Oh. Oh.
What are the odds? We're
Oh.
gonna finish today with this, by the way.
Let's see.
And 1, 2, 3, and go!
Oh. Example, unexpected end of input. So the parsing failed. Expecting a unit, digit, or a value. Or
What
parentheses.
the
Oh,
heck
did you
is
call
it?
parentheses? You didn't.
Wait,
The open
parentheses? What do you mean?
brackets. SW. Go to the SW file. Oh, dude.
What?
Oh, man.
Oh, adding the brackets.
Yes.
Okay, that's definitely a thing. But these error messages is pretty crap. I probably are calling the wrong
Yes.
function.
It is
I don't
pretty
think we
crap.
want the parse one then.
Could it be the pack? I don't know. I remember it was better
No,
before,
it was
wasn't it?
awesome. It was totally awesome.
It was showing the color and everything. I remember we did that.
Maybe it's parse test.
Yeah, it could be. It already gives an IO.
Yeah,
Yeah.
not that we care. So main. Yeah, same thing. I don't think that changing this will matter, but yeah, same thing.
Why
So
is it
line one,
parsing?
unexpected end of input, expecting that. Yeah, this is
I
this is okay, but
I don't
there
think
is a
it's
way to
very.
fix this to at least have better messages to be readable. So we pick the content.
Oh, dude, like we cannot print stuff in the middle without doing all that crap. Oh, we can. right?
Oh, well, we definitely can. Parse, so read file, and then
Oh, dude, do you think? Oh man,
what?
was it really reading the file or was it reading the text? Like examples show. That would be funny. That would be very.
It seems like it, right? Because it is
Yes.
appending examples slash
Yeah,
show
that is very
SW.
wrong. Yes.
Okay, so but then I have a theory. So let me Control Z all this. Control Z all of this. Okay, and
Oh, so
then
that thing doesn't read the file. That's.
put this here.
Oh yeah, it could be.
Could be. We don't know, but it could be. Very modding scope. What are you talking about? Oh, potential.
Content.
No.
Type error. Unbound variable. Examples in
Unbound
environment.
variable examples. Examples.
Oh, dude, it tried to parse the examples folder. Oh no. Dude, just do a text. Let's do a text. Do a file read, man. That's
Okay, no,
disgusting.
but then we can do the
That's
parse test.
inefficient. Yeah, do a file read and do, but that's inefficient, right? We can take a look at there later on the library how to read from a file.
Examples show. Uh, then we can just do
Hmm.
uh,
Parse test content.
parse test content. Okay, very not in scope, makes sense. Okay, what is the return of this? Parse test. Oh, it's IO, so we don't really care.
Yeah, so just print,
So
right?
just do like that. Oh
Yeah, we
wait,
need
then we have a
to.
problem.
We can't pick the message, right?
No, not only that, we don't have access to the AST with
Wait, there
just
is an
parse
example
test.
there. There is an example there. Left error. So it you have that.
No, but
But
that's
oh, on the
the
parse. Never mind.
no, but that's
We're
the
looking at the
thing.
parse
You see
test.
that this is empty and this is the wait. This
Oh,
is the
dude, wait.
content. Okay, so yeah,
Yes.
so we
Yeah.
can do what we think we can.
Yeah,
So
but we can just read the file, right? Instead. And then we just
parse
split.
expression p, then whatever that is, then content off.
Mm-hmm. Yeah. Oh, now import. Parse test. Yeah. Oh, attempt to apply function, blah, blah, blah. Okay, that is not a function. How are we
Attempted to apply
evaluating
a
that?
value. Attempted to apply a value. Wait. Um,
Can you look at the thing? Or is that a Haskell message? That would be funny if you were. Because then it'll be very long.
no, this is a parser error. No, but it's saying it's a type error. What the heck is going on?
Yeah, that's what I'm confused. So look for the message inside the code. Let's see.
No, but what I don't understand is that I put a print. Oh no, but it failed. Ah. Okay, so I want to do the do here. Yeah. So it is a type error, so it means that it error on type checking. So we want it here. Okay. Aha. that is correct. Right?
We attempted to apply. Yes. But
Okay.
it print.
Okay, so we
Okay,
have two
e
options.
application, e variable show. Yes, that's
I'm very
correct.
surprised the parser did that, by the way. But anyway.
Yeah, that's correct.
Okay, so now we have two options. Or our type checking is wrong, or our
Yeah,
prelude is wrong.
it's our type checking, I'm pretty sure. It's
I
our
think
type
it's
checking in the prelude.
no.
It's our annotation probably.
I think
So
it's our
let's
annotation of the prelude, man. I'm pretty certain.
no, yeah, that's what I'm saying. But look at where that thing is. Let's go reversed.
Wait, no, but we are doing kind of overkill. I want to check if the simple ones are working. Some. I think that's it, right? Because we are
Yes.
hardcoding the one.
Yes, but I think we need to change the annotation. But go on.
You need to change the annotation.
Yeah, let's see.
No.
Oh yeah, you didn't change the file.
Oh, I didn't change. I'm dumb. Okay. Oops. Oops.
Okay. Mm-hmm. Correct. What is the annotation of plus?
It
Can you show me?
works.
What is the annotation of plus, please?
Annotation. You mean the type annotation?
Yes, it is
Here.
an arrow from integer that splits another arrow with another integer. Can you put 2 there?
What do you mean true?
Like 1 and then you put 2 in there.
I'm not
On
getting.
the SW, sum.sw.
Oh,
Put 2.
I don't think that's. Oh, true here. You mean?
Yes. No, 1 and 2, both numbers. It should fail, but the type is
Failed.
right. Mm-hmm.
Attempted to apply value L integer to L integer.
Yeah, so change to 3. I got it. It's because the result of the previous expression was 2, and then it tried to do 2, which is now the value,
Wait a
with
second.
the new thing.
This is
Oh,
wrong,
dude!
right? What the heck is this?
Let me see. The application of then another application. Oh yeah, no, that's right. Dude, that's correct. Dude, we did it. Hang on, just a second. Dude, this is perfect because here's what we can do now.
Oh, this is scurried, right?
Yes.
Oh.
So we on the go back to the code on the
Wow.
plus garbage because now we just need to spit another function, right? And that's it.
What do you
Instead
mean?
of doing the one, go back there.
Go
Just a minute.
back here. I think you mean here.
This, yes. So instead of spitting the v literal blah blah blah, do another function that is exactly the same shit. Just focus on the integer case to make it small. Let's just do a thing that picks. Let's try to ignore the most things possible because there's a lot of types like wrapping shit.
Yeah.
So try to spit a write with a function that spits the same shit. You got the idea?
Yeah. So.
Like yeah, v native function, the same thing. Is that right?
Yeah. It's a
Okay,
function.
I'm just confused with this annotation. Weird.
No, it is because we're doing the following. Whatever is after the dollar, we are wrapping with right. And this is a function that picks a v native function.
No, that's not it, right? You should spit a v native function out of this.
I should spit?
It should be like this. Let me send on Discord. You need to spit a. Let me do in F sharp because I'm retarded. Result.
Yeah, but the parser works.
Yes, and I wasn't expecting it to be correct.
We
and
get
then what do we
surprised
think?
by our own stuff.
That's what we want to return.
Yeah,
Because we are returning a type. So
Oh, okay. Oh,
that's
no,
the
no, that makes
yeah.
sense. So you're gonna return a v-native function
hmm
that
That is wrapping the new value.
is wrapping a v literal
hmm With another v integer.
with
You know, in this case, it's an integer, so it needs to be another v, another l integer. No, not v. Yeah, it's
wait, I
a
am very confused because this v-native function needs to receive a function, right? It needs to receive this.
yes, and the value is it's the same thing as the literal you're doing there. So now you match this literal with a l integer. So it's a v literal with
Mm-hmm.
l integer. Just do everything already on the same thing.
Can you help me, please? Because I'm getting confused. You
Yes,
have
okay,
access to
let
the
me
code.
go. Yes, yes.
Ah.
I forgot to form this l integer literal, and then this thing is already part of the function. So this should be this. I think so, right?
Yes,
Oh,
yes,
we need
yes,
in
yes.
parentheses
Yeah,
again.
maybe or dollar.
Or dollar. Let's do a dollar.
Anyway,
Oh,
anyway.
what did I do? Here.
Ah.
This. And from this dude, we do the we spit from this guy a v literal, v integer with the op of the first with the
Oh, this guy is the second.
second. That's it.
No, but there's a problem though. This
Which is
affinitive function needs to receive a value and returns a neither. So this needs to be this.
oh yes, yes, that's right.
Okay, let's see if this
So
compiles.
that's it.
And it doesn't.
It doesn't? Why?
Uh, Oh, it needs parentheses because you're doing pattern matching.
Parentheses. Oh, okay. I see. Nested, right?
Yeah, okay, that worked. Okay,
Now let's see. I'm curious.
3.
It works. Good. Okay, that's it, man.
It works. Good.
Now we just need to solve the show.
Uh,
Let us think.
oh yeah, the
So
show. Let's go back and see the error again.
let's change this stupid annotation here.
Yeah, no, this is the problem. The T for all stuff is the problem.
So here's the thing: we need to pick anything, right?
Yeah.
We don't care if it's showable or not. We assume it is. So we need to pick anything, and this thing go to to this that we will not mention what the thing is.
Oh my god.
And this takes into an arrow that takes this variable to unit. So dude, the type is right, but what was the message that we were can you
Yeah,
run this thing again?
I can. So just gonna comment this. Okay, so attempted to apply a
Attempts to
value.
apply. Let's
T
search
for
here.
all blah 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 blah. That it is not a
Attempt.
function. Attempted
Wait,
to
it
apply.
is attempted
It is a
to
type
apply.
error, so it is on the typer.
Here. Wait, following you, I guess.
Yeah, here.
Yeah. So let's see. How do we get here? So we got something that is not the arrow.
Oh, it's because
While
we parsed as an application, my dude. You
no,
see
but
there?
that is yes, but that is right. Ooh, I see the problem.
Okay, so show shouldn't be parsed
It
as
should
an
be
application.
a T application wrapped a thing.
Yeah, but we don't have parsing for that yet.
Oh, that sucks then. we can't print.
Anyway, this was fun, but I think we're done here today.
Unless if we want to print something, we can do a print from integers to unit. We can try. Let's do that. Let's see.
We can do a print
Yes, that'll be
of
very cursed.
integers to units. What the heck are you talking
Yes.
about?
So let's comment this. Oh, that's not how you comment.
No, wait, I am still confused. What do you mean by printing an integer to...
You see, Lemos. The annotation is. Oh wait, this file is
Where are you, by the way?
here.
Oh, okay.
This. So what is the type now? Let's do just the arrow. that takes
Oh, I
a,
see.
you see, to a T unit. That's it. We could do an either, but who cares? But then we need to do this some kung fu somewhere
Okay,
else.
so
But
let's
anyway,
let's
let's just
see.
print.
Okay, it type checks, and yeah, it
Okay, it
does
doesn't
nothing.
show
It
the
doesn't show.
effect.
It doesn't show the
Yeah.
effect. Yeah, but then I'm confused. How is not showing the effect if the evaluator is asking for the auxiliary stuff?
Yeah, it executed, right?
Wait a sec.
Oh no, wait.
Oh wait,
It
I
showed
know.
the
I know.
result.
Wait. I think is that is that
These Haskell symbols.
I'm almost sure, man. Use bank patterns. Okay, I will use bank patterns. No, man, it's because I think I know why that didn't work. It's because of the laziness.
Oh.
Because we're not using that value, so we never have to
To
evaluate.
eval, yeah, makes sense.
Okay.
Amazing. Okay, but the show is wrong, right? But that's fine.
uh, I think that the worst way to describe today's session is fine, because nothing, everything is wrong, kind of.
Yes. Everything is kind of wrong, kind of right. You
Oh man,
can
this
say, you can
auxiliary
tell.
function is so like what? It's so cursed. Holy balls. Uh, okay, okay. I think at least we know that we have the capabilities of parsing stuff and type checking and evaluating stuff. So and kind checking as far as I can tell. Surprising, very surprising. We are done for the day. I'm gonna finish the recording.